If you want to tunnel the traffic from any other application through Tor, such as maybe your email client, you want that to go through Tor, you have to be very careful how you set it up. The Tor browser is built not to leak protocols, but other applications may not be. For example, your email client may send all the email through Tor and then not do DNS through Tor, instead doing it normally, ignoring its proxy settings. This does happen, it has happened, so you have to be very careful. That is the big worry with using other applications with Tor. Here we're in the Talk defaults file, which shows us we are running the SOCKS port on 9150 and the control port on 9151. So it's a SOCKS port that we care about for setting up other applications, 9150 in this case. If we run a netstat, currently Tor is not running, so the SOCKS port is not there. Let's start Tor. And there we go, we can see it's established here, and listening here is our control port, and there's the SOCKS port that we care about, 9150. Applications such as any browser that supports SOCKS proxies can be configured to connect to this port, or whatever port you choose to assign it as, and tunnel traffic through the Tor SOCKS proxy. So let me show you how you do that in Iceweasel. So here we are in Iceweasel, which is essentially Firefox on Debian. We need to go to Preferences, Advanced, Network, Settings, and here we need to enter what is already entered in here, the local host, and then whichever port we've got it set to. Okay. And that's done the search through Tor. We can check we're on Tor, and we can see here, congratulations, this browser is configured to use Tor. However, it does not appear to be the Tor browser. So of course it does not have all of the hardening and security, and of course we cannot see the circuit and all the other things. Now here we are in the Tor browser, and if we do exactly the same thing, unsurprisingly, we will also see that this is set up to use the SOCKS proxy 9150. We can change the SOCKS proxy port if we wanted to. Save that. Then let's restart Tor. So here we can see the port has changed to 6666, and we would need to configure this to work on the new port. And there we are, going through the 6666 port that we've just set up in the talk file. Pretty straightforward. With SOCKS proxies, each application, so here for example Iceweasel and the Tor browser, uses a different Tor circuit. This protects against identity correlation through Tor circuit sharing, but for optimal separation between contextual identities, I recommend you use separate workstations or machines per identity. You would not want to be even sharing the same SOCKS port, even though you have separate circuits. And just to demonstrate, I've changed Iceweasel back to 6666, and we can see at the same time through the same SOCKS port we are using different circuits. We have different exit node IP addresses. But there's no guarantee that Iceweasel or any application will send all traffic through the Tor proxy. This is the problem. It could, and classically it's DNS that's the problem, send DNSs unproxied. You can't guarantee that whatever application you're using will abide by the proxy setting. If you're going to be setting up other applications, then you need to check for leaks. And Tor has some functionality that allows for that. If you set test socks 1 in the talk file and then watch the logs as you use your applications, Tor will then log for each socks connection whether it is using a good variant or a bad variant. If you want to automatically disable all bad variants, then you need to also set that in the talks file. Obviously save and restart the browser. But really the absolute best way is to look at the traffic using a protocol analyzer such as Wireshark on your router or firewall or on the workstation that the Tor browser is on to see if there are any leaks, and you might want to run it for a little while as well. Personally, I prefer to have it on the router and or firewall as all traffic goes through that if it's going to the internet. On the workstation, maybe something will be missed. In the section on detection and monitoring, network security, Wireshark, we cover this very thing. But let me just give you a quick example here. So I'm SSHing into the router and pulling off the network traffic live with TCP dump and piping it into Wireshark. And there we are, it's doing it now. So let's run some traffic. And there we are, you can see the traffic, DNS query. So I was concerned that there was a DNS request here that was actually being sent out of Tor. So, but yeah, so what that is that's Wireshark itself resolving IP addresses, which is a good example of how other applications that you're using don't go over the Tor network. So let's clear that. But the rest of the traffic that we see is all Tor traffic as is expected. As I said, we cover this in its own section, monitoring and checking for traffic. You should also consider preventing the leaks by firewalling the traffic. Set a deny all rule for everything apart from Tor. See the firewall section for recommendations on firewalls and how to do that for the various operating systems. In the example we've just gone through with Iceweasel, it was easy to send the application through Tor because it supported SOCKS proxies, but not all applications have some sort of configurable way of sending its traffic through a SOCKS proxy. If it doesn't, the Tor project suggests to install Privoxy, which is here, but you're going to need to spend some time understanding Privoxy as it's for advanced users. If you're using an open source router, you could configure Privoxy there and it's easier. DDWRT, for example, has Privoxy set up and there is somewhat of a GUI for it. And Privoxy has an example configuration for Tor with Privoxy. Other than Privoxy, if you're unable to use the application's native proxy settings, you might be able to force the application to use a proxy using something called a proxifier. And here in front of you are a whole bunch of them. Proxy chains that you can see here. I demo proxy chains and how to use that in the area on proxies. But again, just a word of warning, you do also have to trust these proxifiers. Whonix can be used to run other applications through Tor, even if they don't have proxy functionality. Let me remind you about how Whonix does this. What you can see here is a representation of the Whonix workstation here, the Whonix gateway here, and then the 3-hop circuit of the Tor network. First node, second node, third node, and then the destination. The Whonix gateway here acts as both a transparent Tor proxy and a SOCKS proxy. Transparent means that even if downloaded applications aren't configured to use Tor, they will still go through the Whonix gateway and be transparently Torified. Transparent as in transparent Tor proxy. This is a good feature. It means you can download and install things that you need, and they don't need to be specifically configured to use Tor. They can go through the transparent proxy. But note, all trans-proxied apps use the same Tor circuit. So as you can see illustrated here, they go through the same nodes, they'll have the same exit IP address and be seen as the same to the destination. Now SOCKS proxies, on the other hand, is used when an application is specifically configured to use Tor as a proxy. So for example, the proxy settings within the browser. My personal recommendation and the safest way to run other applications over Tor is to use Whonix and use it with cubes if you can. One of the main goals of Whonix is to greatly reduce the risk of any additional software not exclusively designed to use Tor, or indeed proxies to still use Tor. If you install an application on the Whonix workstation, you're good to go without the need to worry about protocol leaks. You don't get stream isolation, but that's better than it not going over Tor. You can use a Tor hardware router with a transparent proxy if your application doesn't have proxy settings, or a SOCKS proxy, or with a SOCKS proxy if your application does have proxy settings, or you can use a router that forwards Tor traffic. You can build one of these yourself, such as the one here, or you can buy a commercial version. Then all traffic routed to the router will be Torified no matter what application it is. There are pros and cons to this, and we have a separate section on Tor and VPN routers. There are some applications that have been developed for blocking non-Tor traffic. Here is Tortilla. Tortilla is a free open source solution for Windows that transparently routes all TCP and DNS traffic through Tor. You might consider this if you want to use Windows and leaks worry you. I would not recommend Windows though, but you still could use this as a gateway via some sort of virtual machine, and you wouldn't have to be using Windows as your main workstation. This is Corridor. This is a Tor traffic whitelisting gateway. This allows only connections to Tor relays to pass through, so no clear text leaks, but client computers are themselves responsible for Torifying their own traffic. In other words, it is a filtering gateway, not a proxifying gateway. Again, set up to prevent leaks. You could also use this in a VM as well, but as I've said, you have Whonix pre-built anyway. So those are the various options for getting any sort of application to go through Tor, making it as safe as possible.